Mr. War here at your service, and welcome to another math video as we take on this common core. That's right. It sounds pretty exciting, doesn't it? Hey, I see we got our doggy back. Yippee! Welcome aboard, my friend. I know, you're thinking, Mr. War, you're still a dog. You've been a dog for a while. Hey, what can I say?
I like dogs. Come on here, dog. All right, kind of get going here.
Let's start this video. 3, 2, 1. Okay, here we go. And the first things first here is we have our magic pen. That means I might be giving you the code. No, I'm just kidding. I'm just going to put a little blue dot, which will disappear. Now what we're looking at here is topic A, which is equivalent fractions. Equivalent, meaning the same, equivalent, same value. That's what equivalent means. Important word for us to know for math. Okay, bring it on down. What's our objective here? Our objective here says that students will be able to make equivalent fractions with sums of fractions with like denominators. Of course, like means the same. So we're going to be looking at that as my blue lines disappear. Goodbye. Okay. Yes, okay. Let's move on. Application problem. Here we go. Application problem. Why did I put those two lines there? Just because it was fun. Okay, so I am going to do this though. Ooh. It says here, Mr. Hopkins has 1 meter wire he is using to make clocks. Of course, I'm going to read this problem first, understanding it says each 4th meter is marked off with 5 smaller equal lengths. If Mr. Hopkins bends the wire at 3/4 meter, what fraction of the marks is that? Woo-wee! Tell me that doesn't make your head kind of spin. Oh, hold on, the ride, it's making me dizzy. All right, well, let's slow this down. You know, when this happens, no need to panic. Please do not dial 911. This is not that situation. What we're going to be doing here is we're just going to break it down piece by piece. Mr. Hopkins has a 1 meter wire. So you have to think of what a meter is, and you know what a meter stick looks like. So this is simply a wire that has that length. He's just using it to make clocks, hence our clock. Hello, clock. And it says each 4th meter. Okay, I'm going to get another pen. Each 4th meter, fourth. Doesn't that make you kind of think of a fourth? 1/4. So we're going to just kind of write that down. Each 4th meter, okay, is marked off with 5 smaller equal lengths. Well, let's just take the first part of that. That each 4th meter is marked off. Well, each 4th meter means assuming that we have 1 meter, and then we're going to mark it off in 4. So let's just go ahead and do that first. Okay, tape diagram, I'm sensing here. Okay, there we go, make it nice and large. So basically, we want to make 4. So let's do that. Should I take my line, make my line look a little bit neater. So we'll do somewhere like in the middle. That's a half. So I can do 4ths this way. Oh my goodness, Mr. War, your lines are so perfect. Yeah, I knew. I like smart. All right, and I'm also going to mark off because this is like our 1 meter. This is the wire. It's 1 meter. We okay with this so far? Okay, we did 4s here. And now it says that this 1/4 here, since this is 1/4, 2/4, 3/4, 4/4 to make one whole, it's marked off by 5 smaller equal lengths. Well, let's go ahead and pull up my little black square. You wonder, what is this guy doing here? This is his job. Ooh, a little bit too big. There we go. Try to make him fit. Pretty close, I would have to say. Okay, and so now we have, like, why did I put this here, you're wondering? Well, if this is 1/4, 2/4, 3/4, it says that at each 4th meter, it's marked off with 5 smaller equal lengths. So let me go ahead and show you that this is basically what we have. We have 1, 2, 3, 4, 5. So I'm just showing you that there's just the equal length. I could actually draw the lines here as well, so you could see that. but I was kind of lining it up next to it so you can see that there's 5 smaller equal lengths. Okay, so far I've done that. Now it says if Mr. Hopkins bends the wire at the 3/4 meter. So here is our 3/4 right here. It says if he bends the wire 3/4 meter, what fraction of the marks is that? And you're referring to these marks here, the 5 smaller equal length marks. Well, if we have 5 here, this is where we need to come and do that 1 unit here real quick. Or when we look at units. So we think that, first of all, the 5 units that we have here is equal to 1/4. So let's go ahead and write that down. So 5 units is equal to 1/4, okay, which we see here. And then, so if we're trying to find out what mark is this, well, wouldn't that be 5 times 3? So like 5 units times 3. And that's going to equal the 3/4 mark. Okay? Everybody good with that? Good with that? And then, so that would give us 15 units. And that's going to be equal to 3/4. I'm just writing this all out. So, but this doesn't tell us what fraction of the marks is that. That tells you, basically, yes, we have 15 marks here, but that's not a fraction. 15 isn't a fraction. So, well, we could look at this and say, well, what fraction is that of the whole? Well, the 1 meter, if we had 5, 5, 5, and 5, that's 20. So wouldn't that be 15 then out of 20? Which again is equal to our 3/4. Because if we had 20 out of 20, that would be the entire wire. Here we have up to this mark right here, up to the 3/4 mark. Now, if we look at this, we can see how they're equivalent from the other lesson. See, it just so happens that we have 15 over 20. If we multiply the numerator and the denominator by that same quantity of 5 and multiply that, we end up with 2 equivalent fractions. Okay? And so basically, we can say now that, to write this in words, that, Mr. Hopkins, he bent the wire here at the 3/4 meter, or on the marks, that would be 15 20ths of the marks that they're all going across here. Now we can also show this as a number line, which we want to do here. So let's go ahead and bring this down, and then hopefully I'll have my extend page down here. No, I don't see that. Why don't I see my extend page? Maybe I put this up here. Might be this thing here too. No way to move page. Abracadabra, move page. No, not going to work for me. Okay. Well, what I could do, I know if I went in here, come back here, and what could I do? Oh, I could hit X here. I think that's what I need to do. I knew it. See, I know smart. Okay, so now we'll hit extend page. That way, bring this down here. Perfect. Because what we're just going to show you here is on a number line. It's real important that a lot of this work you have to kind of show your understanding. You know what I'm saying? You hear me? So here, if this is 0, this would be like our 1/2, okay? And I've already got this divided up into quarters, looks like to me, okay? And then remembering that this was our 3/4 mark of the wire where he bent it, okay? Of course, then that would mean that's 4/4. 4/4 is equal to 1/2. This is our halfway mark, which is same as 2/4, equivalent fraction. Here's our 1/4, and then we put 0 over 4. So you see how the numerator just every time, it's very sequential. They go right in order, and the denominators are the same because that's how we've divided it. So what we could do now is we could actually show those 5 equal marks that we had up here on a number line. 1, 2, 3, 4, 5 in that first quarter. Okay, so in this case here, we could say that really 1 mark on here, on our number line, and also with a problem, is 1/20th meter. I'm not trying to confuse you, but we looked at this and we saw that this equaled 1 meter, 1 whole meter. Therefore, each one of these marks is 1/20th Okay, and then of course when we get to that 3/4 mark here, that's going to be that 15/20ths. Okay, again, just another representation to show you on this problem here. That was pretty much what I wanted to show you that. All right, and I should probably do that too, I think. Trying to remember what letter I left off on. Oh my goodness. Okay, next page. So let's go ahead and look at this. Is the real concept development. That previous application problem is kind of leading us into what our focus is today. And our focus, in case you guys are lost here, our focus is right here. This is our purpose here. You're going to use the sum of fractions. You're going to make equivalent fractions, but with sums of fractions with like denominators. And that's what we're focusing on here today. So let me go ahead and write our problem for this particular one here. Here, let's go ahead and put 1/3, okay, plus 1/3. So you can see this is exactly what we're trying to show. This is 2/3. Now, our denominators are like denominators. That's what it means by that objective, right up there. They're the same denominators. When we have the same denominators, we can add them. We can't add fractions if they don't have the same denominator because it's indicating that that whole has been divided up in a different unit. This unit we have 1/3. Okay, it's a unit that it's been divided into. So now basically we have 2/3. Now how can we show this on a number line? Well, we can basically show this. We always have our 0 here, right? Starting off point. We can show this as our 1. Therefore, that would be 3/3, and this would be no thirds, right? 0/3. So basically we need to make sure that we've divided our whole now into 3 equal parts. So I'm just going to kind of estimate here. Not perfect, but close. Okay, so this would be 1/3, and now this would be 2/3. Now really, this, with working with fractions, I know it's a different value of a number, and you're not used to maybe working with fractions because we typically work with whole numbers. But when you start to when you keep working with fractions and showing this on the number line, it starts to make more and more sense. Because like 1/3 here, so we go ahead and let's show this. If we're adding them, we could show this with this arrow that I've conveniently put here. Okay, that here becomes that first 1/3. Now we're going to add another third. So let me go ahead and grab another arrow, put him here, see if this is going to work out. Oh, this guy, he just said, I'm not doing that, Mr. Worry. I'm staying. You know what? I'm not going to be flipping like you did with my friend over there. You know what? I'm sorry. That's your job. It's your job to be like that. Thank you. Come on, move over. There you go. See, that didn't hurt. So now we have 2/3. So we could show this now by writing this out. Let's write. So if we have 1/3 plus 1/3 is going to equal 2/3 like we had up there. That also means then 2, we could say 2 times 1/3 is going to equal 2/3 because we have 2 of them. And like with addition, you know, we can multiply, showing a faster way there to add. Okay, seems fair enough. Let's move on to the next page. But first I'm doing this. What? Did I do this yet? Okay. Oh, it always does that. Okay. Just one of these. It's not working. All right. So since that didn't work well, I'm going to make sure that you don't get confused. I only want one of these, okay? Not like 5 of them. That wouldn't make sense, would it? Okay. So moving on to the next page. Thank you very much. Yes. Oh, the camel, you're back. Hey. Nice to see you, my friend. What are you doing here, though, really? Really? You're like all tired and everything? A 2-hump camel. You need like a goatee. That would be really cool. Like have it like a beard. There you go. Okay. Yeah, maybe a longer tail. No, so let's get serious here. We have a problem here now. It looks like we have 6 halves. Okay, is equal to the 2 halves plus 2 halves plus 2 halves, which is equal to 1, 1. Okay, what is all of this? This is just, well, let's look at this and piece by piece. First thing is 6 halves. Okay, it's saying that I've broken up my number into halves. That's the denominator indicating that. So, and I have 6. So if I had, you can think of a half, 1/2. I'm saying that I have 6 of those. Well, now you have 2 halves here, so 2 plus 2 is 4. 4 plus 2 is 6. So 6 halves. The denominator didn't change here. Well, each one of these 2 over 2 we know is 1 whole because we have 2 groups of 2. So now here we have our 3, which equals 3. But basically what we're going to do is we're just going to show this on the number line. Okay? And let's go ahead and put our 0. In this case, we're going to show our 3 because this is what our amount is here. And we could show 1, but then a number line wouldn't have everything we need to see, so that number line would have to have a 3 here. And since we're dealing with whole numbers here, it would make sense that 1 and 2 are going to be right there. So now we have 0 halves since our denominator is halves. And then over here, we're going to have 6 halves because we have 3 wholes, and we already decided 6 halves is equal to 3, so we're just trying to show this. So how many halves would we have here and here? Well, 1 whole we know is 2 halves. That makes 1 whole. So to get 2 wholes would be like 2 halves plus another 2 halves, which is going to be 4 halves. So you start to see the pattern here in math. You start seeing the 0, 2, 4, 6. That should kind of give you an indication. Now, we want to understand the value, half. Okay, that's half of 1. Okay, and why I put a 4 down there, I have no idea. I don't know. You should be a half too. Thank you. And there you go. And then here we have 5 halves. Because actually 3 halves is 1 1/2, and 5 halves would be 2 1/2. And that makes sense because 2 and 3, that's right in the middle. So easy. All right. I know. Come on, come on. There we go. So trying to show that first whole that we had, and then I'm going to do another one. See? And then another one. And that's showing the addition. That's why I want to show you with those arrows there, that we're basically showing that 2 halves plus another 2 halves. Another 2 halves is 6 halves. Okay? A lot of work for that problem, I would have to say. And that's just kind of how it is. And I think that's where we are. Well, I'll give you that one too. Now, I have to think out loud. Okay, last one here. Ooh, Mammoth. Hello, Mammoth. What are you doing, man? Can't really see you. You're really dark, huh? Just you guys being a little bit more gray. I'm sorry, Mammoth, but all right. I guess I'll let you stay on the page here. You're kind of cool. Stay right there. I don't know what it is, Mr. Warrior. What is it with you and animals? I don't know. I like animals, huh? Hey, let's move on. Now we have a situation here. We have 8/5. Okay, different denominator. We do. And now what's saying here is 8/5 is equal to 5/5, which we should know at this point that 5/5 is equal to 1 whole, and then plus 3/5. Well, 5 plus 3 is 8. 8/5. Okay. And it's saying it's equal to 1 3/5. So we want to show this on our number line. It's a great way to get the problem right on a test. No, it's a good way to understand math is by visualizing it. So let's visualize this one. So again, we're having our situation where we have 0 here. That's kind of a starting point. Okay, we have 1 3/5. So I'm just going to go ahead and put 2 because 2 would cover that, which means we'll not get all the way to 2, but somewhere in between. Now, if that's 2 and that's 0, I wonder what this one is. Is it 1? Yay! Okay, so now we have 0, 1, 2. This is just getting so easy, isn't it? I know. So here we have 0/5 because that's the denominator that we are using. And here, you might not know what that is, but we definitely know 1 whole is 5/5. Very good. So if we have 5/5 here, 2 wholes, that's like double that, would be 10/5. Okay, and so now we can go ahead and show this. Now since these are fifths, we could divide this up, showing 1/5, 2/5, 3/5, 4/5, something like that. Okay, and we could do the same thing here. 1, 2, 3. Okay, now here's our fifths. Now, the first one, it says we're adding 5/5 plus 3/5. So, yep, that's right, Arrow. It's time to get to work. Okay, so we're going to show the very first one here. And a little bit more. Thank you. And we'll put you a little bit above. Yeah. Okay, so that's that first 5/5. But now we need to add 3/5. Well, we already divided our whole from 1 to 2 into fifths, so let's go ahead and do that. We'll bring this one here. Here's 1, 2, 3. So it's going to go right to here, right? Something like that. Now, so let's look at our number here. If this is 5/5, this must be 6/5. This is 7/5, and then 8/5, and this one's 9/5. Wow, that just doesn't get any easier, my friends. So 8/5 is what we're looking at right here. And it's interesting, that's our 3/5 too. 1, 2, 3. Okay, so this was our 3/5, and this is our 5/5, or 1. When you add those together, you get your 8/5, which is down below. Or it's 1 and 3/5. Wow, what an amazing video. No, it's just a regular math video, my friends. However, we learned, when we look back at our objective, we learned that we can make equivalent fractions with sums of fractions with like denominators. Is basically what we did. And we did a lot with number line work, which is really, really important. And so where am I at now? I think I'm here. I believe, I hope, thinking in my mind, if I gave you all the correct letters, I believe so. That, my friends, ends this video. It is now time for you guys to go on and live long and prosper. Adios.